Okay, we've got two quantities, A and B, and we've got their rates. Given f is that, find the rate of change of f. So we want df dt, and then we have the first times the derivative of the second plus the derivative of the first times the second plus 6b squared db dt. So everything is differentiated with respect to t. Okay, so now we sub in A is 1 and B is 1, and the rates. So we have 2 times 1 squared times 2 plus 4 times 1 times 3 times 1 plus 6 times 1 squared times 2. So that's 4 plus 12 plus 12, so 28. So we've got same situation. So we have 2f df dt equals the first times the derivative of the second plus the derivative of the first times the second. Okay, so now we've got A and B are 1. And we need f. Okay, so f is going to be, so f squared is 2 times 1 squared times 1 from the original thing. So we're going to have f squared equals 2, so f is plus or minus root 2. So plus or minus root 2. So we are going to have 2 plus or minus 2 root 2 df dt equals 4 plus 12, which is 14. And then we will divide by plus or minus 2 root 2. So that's plus or minus 7 over root 2. All right, so air is pumped into a spherical ball which expands at a rate. So we have the volume is expanding at a rate of 8. Find the exact rate of change of the radius of the ball. So we're looking for dr dt when r is 2. So we have the relationship between volume and radius is this, and then we can differentiate both sides. And now fill stuff in. So we're going to have 8 equals 4 pi r is 2 dr dt. So we're going to have 8 equals 16 pi dr dt. So we've got 1 over 2 pi is dr dt. And that will be in, so that's radius centimeters per second. Okay, so the following shows an isosceles triangle with AB is 10 and AC is equal to BC. C is moving in a direction perpendicular to AB with speed. So the derivative of height with respect to time is 2. Calculate the rate of change of the angle CAB. So we want d theta dt when theta is 60 degrees, equilateral. Okay, so if we take just this triangle, we want this angle and the height, so we're going to have tangent. Okay, so tangent theta is the height over 5, just that side. So we will have secant squared theta d theta dt equals 1/5 dh dt, and we have dH dt is 2. We're looking for d theta dt, and we're going to have 1 over cosine 60 degrees squared, just to bring it back. All right, so cosine 60 degrees is 1/2. So 1/2 squared is 1/4, and that is equal to 2/5. So 1 divided by 1/4 is 4. So d theta dt, we would divide, let me just write it. So, dt. So d theta dt is going to be 2 over 20, 1 over 10, and that would be in radians or degrees per second. Okay? All right, this one. An airplane's flying at a constant speed at a constant altitude of 3 kilometers in a straight line that will take it directly over an observer at ground level. At a given instant, the observer notes that the angle theta is pi over 3, and its d theta dt is 1 over 60 radians per second. Okay, so find the speed in kilometers per hour. So let's first of all change this to radians per hour. So we're going to have 60 seconds in 1 minute and 60 minutes in 1 hour. So those will cancel, those will cancel. So we're just going to have 60 radians per hour. Okay, so now we want the speed of the airplane. So we'll just call that dx dt just because it's that. So that's what we're looking for. And we need a relationship between theta and x. Okay, so by parallel sides, this is theta. So we're going to have tangent theta equals 3 over x. So secant squared theta d theta dt is going to be negative 3 over x squared dx dt. So now we have secant squared pi over 3. D theta dt is 60. And we have negative 3 over x, which we don't have. We need to solve for that. So we have to do tangent pi over 3 is going to equal 3 over x. Tangent pi over 3 is root 3. Okay, so we're going to have x is 3 over root 3. So that goes down here. And we want dx dt. Okay, so secant squared is 1 over cosine squared. And at pi over 3, cosine is 1/2. So secant's going to be 2 squared, which is 4, times 60 is 240. And then we're going to have negative 3 over 9 over 3, which is 3. So this is negative 1 dx dt. So dx dt is negative 240, and that's kilometers per hour. Now B, find the rate of change of the distance between the observer here and the airplane. So we'll call this hypotenuse, h, at the instant when the angle theta is pi over 3. Okay, so you can use a trig identity, or you can use Pythagoras, or, yeah, so if you have x squared plus 3 squared equals h squared, we're going to have 2x dx dt plus 9, which goes away actually, and 2h dh dt. Okay, so the 2's can go away. All right, so x is going to be this, and then dx dt, because this is all happening at pi over 3, which is the same situation for a. So dx dt is negative 240, and h we have to find out because we're finding, the whole goal is to find dh dt. So we're going to find out h. So we are going to have 3 over root 3 squared plus 3 squared equals h squared. So this ended up being 3 here. So 9 over 3 plus 9 is h squared. So we have h is square root 12, which is 4 times 3, 2 root 3. Okay, so if we divide by 2 root 3, we're going to have dh dt is, so 3, those all cancel, and then this is negative 120. And this is in kilometers per hour as well. Okay, number 8, a ladder 10 meters long is leaning against a vertical wall. The ladder is sliding down the wall, and the bottom of the ladder moves away from the wall at a rate, so let's call that dx dt, of 0.5 meters per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder, okay, so at x equals 6, this distance, how fast, so we want dy dt because we want to know that rate going down. So this is y, this is x, so obviously our relationship here is Pythagoras. And then we have 2x dx dt plus 2y dy dt equals 0. So 2 times 6 times 0.5 plus 2 times y, which we have to find out. So that's 6 squared plus y squared equals 10 squared. So 100 minus 36 is 64. So y is going to be plus or minus 8, but 8. And then dy dt is what we're looking for. That should be negative because it's going down. So now we've got 12. Half of 12 is 6. So negative 6 divide by 16. So negative 3 over 8, and this should be meters per second. All right, a particle moves on the curve with the equation that where x and y are measured in meters. At some instant, the particle is at a point where x is 2 and y is pi over 6, and the rate of change of x is that. Find the gradient at that instant. So we've got first times the derivative of the second plus the derivative of the first times the second equals 0. So now we've got 2 squared cosine pi over 6 dy dt, which is what we're looking for. Oh, dy dt. We're looking for dy dx. We'll deal with that in a second. All right, so plus 2 times 2 dx dt is 5 sine pi over 6 equals 0. So we've got 4 cosine pi over 6 is root 3 over 2 dy dt. And then we've got plus 20 sine pi over 6 is 1/2. So this is 10 equals 0. So we're going to have 2 root 3 dy dt is negative 10. So dy dt is negative 5 over root 3. So dy dx is dy dt over dx dt. So we've got negative 5 over root 3 over negative 5. So, over positive 5, sorry. So that's going to be negative 1 over root 3 meters per second. Okay, and then B, find the rate of change dy dt. Okay, so we already did that. Okay, a conical tank with its vertex down is 8 meters in diameter and 12 meters deep. Water flows into the tank at 10 meters cubed per minute. So that's dV dt, 10 meters cubed per minute. Find the rate of change of the depth when h is 6. Okay, so what we have here is like this. We want the rate of change when that. So these ones are always kind of tricky to set up. So what's going on here is you have similar right triangles. So you have the larger one, which is 4 and 12, and then you've got the smaller one, because these are both changing. You know, this radius here is getting smaller and this height here is getting smaller. So if we set up a proportion, 4 is to r is 12 is to h, we've got 4h is 12r, and I'll just solve for h just because it gives not a fraction. Okay, so h is 3r. So now we need volume of a cone is 1/3 pi r squared times the height. So we don't have, so the reason you have to do this over on the left is that we have r squared and h here, and we don't have, we're looking for dh dt, but we don't have dr dt, okay? So we need to, actually, I need this to be r, okay? So if we now do dv dt, hold on. So this is 1/3 pi, r is h over 3 squared times h. Hold on. So volume equals 1/3 pi. H squared times h is h cubed over 9. So we're using 1/27 pi h cubed. Okay, so now we can do dv dt is 3/27, which is 1/9 pi h squared dh dt. So dv dt is 10. H is 6. And we're solving for dh dt. All right, so we're going to have 90 over 36 pi is dh dt. So if we divide that by 3, 30 over 12 pi, and then divide that by 3 again, okay, 6 should have been, and then 2. And this is dh dt, so this is in meters per minute.